Okay, Mr. Fong here. Here we go. Today's lesson, linearizing data. So, what you're used to in previous math lessons and our constant velocity lessons, you will have a straight line. The data gives you a straight line. But what if the data does not give you a straight line? That's what this lesson is about. How do we get a slope out of data that does not give you a straight line? So, this is what we're used to. Linear relationship, y equals mx plus b, very common. And notice the straight line means y and x are directly proportional. There are other relationships you've learned. There's the power relationship, so it looks like a quadratic here, or power to a half, that is a square root relationship. Those are curves though. How do we get a slope out of these curves? That's what we're working on today. And the third kind is inverse. So you can have inverse, just a straight inverse, 1 over x, or inverse squared. Notice the shape is very similar. And if you're talking about a scatter plot, it's very difficult to tell which is which because in experiments, the data doesn't fit exactly, right? So what we're going to do is trying to turn these types of graphs that are curves into a straight line. And when we have a straight line, and this is the key here, when you plot two quantities and you end up with a straight line, the result is that whatever those two quantities you've plotted, they are proportional. And you can use y equals mx plus b as a way to write down the equation. So this is your very basic linear relationship. That is, the data is already linear. That is, they are already proportional to each other. What happens when they're not, you'll get a curved line. For example, here we have force on the y-axis and time on the x-axis. And we see that the relationship is linear. So this is kind of a given. So you know from theory that the relationship is linear. So it's very simple. You plot the line, you will have a straight line, and force and time is directly proportional, and the equation is now F equals mt plus b. So F is what's on the y-axis, t is on the x-axis, whatever is on the x-axis is the time, and b is your standard y-intercept. Next example, we have the curved line, the power example. So you know that the relationship is a power relationship, that is some sort of quadratic, for example. And when you plot it, you get this kind of curved line like a parabola. What do you do? Well, first you have to realize that force is proportional to time squared, probably, right? In terms of a quadratic. And then to figure out the equation is just writing it as a time squared. And when you plot those two, force and here, time squared, you would get a straight line. Remember, when the two things are proportional, you would get a straight line. So what we're saying here is that force and the square of time is proportional. And when we plot it, we would get a straight line. And the equation is now F equals AT squared plus B. So notice now it's now T squared because the relationship is squared. So what we're really doing is replacing time with time squared, and we will get a straight line. So if you think of this as x, we can let this equal z equals x, for example. So now y is proportional to z, and z is just replaced by t squared in this case. Let's try another example. Inverse. So we know from the shape that this may be an inverse relationship, or from the theory that this is an inverse relationship. What is the force proportional to? The force is proportional to the inverse of time. So when we plot the force versus the inverse of time, you would get a straight line. And again, the equation is now F equals 1 over T, A being the slope instead of using M, just so that you don't confuse it with the original equation or the original graph. Once you've processed it, you're inverting the time and you would get a straight line. So next, you can give it a try on the lesson that is attached. And after you're done, I will assign you the next assignment with a spreadsheet. If there's any questions, let me know. I'll see you soon.